This is a video tutorial for interpolating to find a draft for a given displacement. This method of interpolation will work for any set of values from any set of tables, so this can be used across many different subjects. In this instance, obviously, we're talking about stability. So my given displacement is 15342. Let's say that we are in salt water. Okay, I need to find a draft for this value. So the first thing to do would be to look in the hydrostatics to see if we can find that value. So we're in salt water, so we're looking at the salt water column for displacements. We're looking for 15342. You'll see there is no 15342. However, we have got values surrounding it, being 15507 and 15274. My displacement lies between those two, so therefore my draft must lie between these two tabulated drafts. So I'm going to get this information out and onto the page. So the first tabulated, it doesn't matter which way around you write these, I'm going to start with 15274. And the draft for that is 7.3. Then I've got 15507. And the draft for that is 7.40. So that's us done with the hydrostatics. You'll see how I've laid this out. I've got my displacements across the top and the corresponding draft at the bottom. The draft that sits below this value, they must be corresponding with each other. It doesn't matter if the lower values are here or here, as long as this displacement is for this draft and this displacement is for this draft, they can be written either way round. My displacement sits somewhere between the two of these at 15342. So I'm obviously looking for a draft that sits somewhere between these two. This is the way how you can check whether your interpolation is correct. Your final answer will always lie between these two tabulated values. If it doesn't, then you know you've made a mistake somewhere in your calculation. At the college, we use a simple interpolation method using the formula A divided by B multiplied by C, where A is the difference between those two, so my displacement and one of the tabulated displacements. B is the value between the two tabulated displacements, and C is the difference between the two values that I'm looking for, in this instance, draft. So if I get the values for each of them, A, the difference between these two, is equal to 68. B, the difference between these two, is equal to 233. And C, the difference between these two, is 0.1. So now I can pop these into this simple formula. So 68 divided by 233 multiplied by 0.1. A divided by B multiplied by C. So 68 divided by 233 multiplied by 0.1. So this gives me a correction to apply. Because draft is only to 3 decimal places, I'm just going to use this number to 3 decimal places. So 0.029. So that's a correction that I'm going to apply to the tabulated value. And the important thing to remember with these corrections is you always apply it to the number that is in the bottom left-hand corner. You see I've drawn my arrows in that direction. It's because my numbers are going in that direction. Okay, it doesn't matter if they're increasing or decreasing. In this instance, from here to here, my numbers are increasing, so I'm going to add this correction to 7.3. If they were decreasing, I would subtract it. So now my draft is equal to 7.30 plus 0.029. So the draft for 15342 2 tonnes is equal to 7.329 metres. And that's how you interpolate. You see this number lies between these two, so I know that I'm within the right areas. I've got my A, B and C values correct, and I've added it to 7.3 because the numbers were increasing in that direction. Okay? Always add it to the value that is in the bottom left-hand corner. Never this one.